Okay, so then today we're going to do the second part of the proof of the general formula for the second order differential equation. Okay, so again, you make this substitution, then you transform the second order differential equation into the quadratic equation. Then you have a quadratic formula to solve that equation. Okay, so we have this formula. So the general formula for this is x equals minus b plus minus a square root of b squared minus 4ac over 2a. Okay, so when you had two different roots, that is the case one, then you have, for this case, you have b squared minus 4ac bigger than 0. So that's why you'll have two different roots. You will have two different roots. Right? Because why? Because you have plus and you have minus. So you have this one and that one. And then we saw that the solution will look like this. E to the m of x and e to the m2x. Now, today we do the case 2 and the case 3. So case 2. For the case 2, and you know, this is a little bit probably too much for one class, but it's gonna pay us back because we are just gonna solve these equations using quadratic formula. So that's a good price to pay. So right now, but then we just use the formula later. So for case 2, I only have 1 0. Okay, so for that case, for case 2, then I have that b squared minus 4ac equals to what? If I only have 1 0, b squared minus 4ac should be equals to 0. Because if it is not 0, I will have plus and minus. Okay, so if this is b squared minus 4ac equals to 0, then my 0 is x equal minus b over 2a. No, my x, or x, no x, sorry, m. I'm using m, right? M. And here is m, this m, right? So my only m is minus b2a, so that's what this case is, repeated real root. So it's called repeated real roots. Okay? Because you have only one root. So it's basically the same root. Okay? So that's this case. So we have only one root. So my solution look like y of x equals, how my solution looks like. So remember, I'm using this substitution because I'm guessing that I have a solution of this form. So how my solution looks like? What is my solution? If I only have one root. Yeah. So my root is just e minus b to the 2a, because that's my only m. Okay, so that's my m, because I'm looking for a solution that looks this way. Okay, I'm kind of guessing. So I got lucky again, and I got that I found one solution. That's my y1x solution. So I have one solution, but this is a second order differential equation, so I need two solutions. How can I find my second solution? If you have one solution, how do you find your second solution? Do you have a formula for that? Yeah, we do. That was the formula we used last time. It's called the reduction order. So using uh, using reduction order formula, using reduction order formula, what is that? That is y2 of x. The second solution looks like y1 of x, integral of e to the minus integral of p of x dx over y1 square of x dx. This is my reduction order formula. Remember we used it last time. So, and the equation look like this. So general equation is y second y prime plus p of x y prime plus q of x y equals to 0. Okay, so that's the formula for this, right? So in this case, what is p of x? So if I have my equation is, how my equation looks? My general equation looks like, how does it look? My general equation. Remember? No, my differential equation. The differential equation I want to solve is this one. So my differential equation is a second y prime plus by prime plus cy equals to 0. So I want to apply this formula. So what should I do? I want to apply the reduction order formula. Thank you. Divide by a. So we got second y prime plus ba y primes plus c over a y equals to 0. Okay? So we divide by a. So what is p of x? Second? B over a. Okay? Why? Because look at, this is the next to y prime. This is the next to y prime. So I use my formula. So my formula says y2 of x equals y1 of x. So, well, y1 of x, we know what is y1 of x, right? So y1 of x is e to the minus b over 2a. So let's put it. So this is lower here. Right here. Y of 2x equals e to the minus b over 2a integral of, on the bottom, I have y1 squared to the x. So what should I write? E to the minus b over 2a squared, right? Because that's the formula. y1 square of x. E to the minus integral of p of x dx. What is p of x? What is p of x? B over a, thank you. And then we have d of x. So that's the end of the formula, right? So let's integrate this. y2 of x e to the minus b over 2a. So that gives me, what is this integral? E to the, this one. Yeah, minus bx over a. Over, and then you plug in this inside. So you get e to the minus 2b over 2a dx. And then I forgot dx, sorry. Right? And I forgot dx here, sorry. e minus b2a x. So please put the x here that I forgot it. So this cancel, and this, then the whole thing cancel, right? Minus bxa cancel with this one, right? So I got the integral of e to the minus b over 2a integral of 1 dx. And what is that? X. Thank you. So x. Oh, sorry, I'm forgetting the x. My goodness. X and x, right? Because it's y1 of x, so that must have x. So this one is x e to the minus b over 2ax times x. That's your second solution. So, conclusion. Your general solution when you only have one zero is C1 of the first solution, that is e to the minus b over 2ax plus C2x e to the minus b over 2ax. But really, we usually just say C1 e to the mx plus C2x e to the mx. So whatever, you find your m and you just place it and then multiply times x the second. So you have to find m. No, because this already has the constants. And it's second order. Because it's second order, you just need two constants. So more constants is redundant. You don't need more constants. Because it's second order. Okay? So that's the case 2. So we are done. We're done with this one. Now case 3. So case 3, it means case 3. So if you look at it here, your parabola doesn't have zeros, real zeros. So that means the solutions are imaginary. Why do they have solutions? Because how do I know that the quadratic formula has solutions? Because the fundamental theorem of algebra. You guys took a fundamental theorem of algebra. I mean, you probably don't use it very much, or you forgot it, but in algebra they told you that if the polynomial has degree 2, then you have 2 zeros. If it has degree 3, it has 3 zeros, and so on. So this one has 2 zeros. They could be complex, they could be only one but multiplicity 2, so it's repeated, or they are real different. So that you count it like 2. Okay? Either way. So you said degree 2 has 2 zeros. Okay, so what we do now, so we have this case, the parabola is like that. So if the parabola is like that, that means I have complex values. So let's see, how do we write this? So we have complex values. So we have two m values, right? So n1, let's use this notation. That is kind of a standard. Alpha plus I beta. That's your first root. That is complex. So if n1 is that, what would be m2? If this one is your first root, what will be your second root? It will be the conjugate. It will be alpha minus I beta. Okay, that's important, this relationship. In the quadratic formula, if you have one complex, the other one is the conjugate. Okay? So that's going to help us a lot. So you are in the first case. So in the first case, you had two different zeros. So your solution looks like y of x equals C1 e to the first root plus C2 e to the second root. We could just leave it like that, but we don't like complex. It's kind of difficult, okay? Because that we don't have too much intuition, so we're gonna do it. We're gonna write it in a better way, but that could be the answer. But you see, the it's not very nice. So n1 is e to the alpha 1 plus I beta x plus c2 e to the m2, that is alpha minus I beta x. So we expand this. So we go c1 e to the alpha 1x times e to the I beta x plus c2 e to the alpha x times e to the minus I beta x. So now we rewrite this one. So we got c1 e to the alpha 1x. So what is e to the I beta x? You guys know? Have you ever seen this? What is? So let me teach you something interesting. So what is e to the ix? This is called Euler formula. He was one of the greatest mathematicians, Swiss. So there are not many great mathematicians, but this is like 7. They're like 7. They do any area of mathematics, they work. So this formula is famous. Cosine of x plus I sine of x. This is called Euler formula. Okay? Have you guys seen it before? No? Okay, so this is good. So you're gonna see why do we like it. So we have then, so we replace over here cosine beta x plus I sine beta x, right? Plus, because right, so I have x here, so x, right? But now I have beta x, right? So I just replace beta x. So this is plus c2, you have e to the alpha x times cosine beta x minus I sine beta x. So that's what we got. So this is alpha x. So now we expand it. So we get c1 e to the alpha 1x times cosine beta x plus I c1 e to the alpha 1x sine beta x plus c2 e to the alpha x times cosine beta x minus IC2 e to the alpha x sine beta x. Okay, so then we factor cosines with cosines. So this is no alpha 1, alpha, right? So I just have alpha. I don't have alpha 1, alpha 2, just alpha. I have alpha and beta, right? Because that's the convenience of this. I have one alpha and one beta, and it's the same for both. It's not like I have alpha 1, beta 1. No, I have the same alpha and beta for both. So that's what I'm going to be able to do, write this better. So then I can factor cosine of beta x. So if I factor cosine of beta x, I got cosine of beta x, right? But multiplying, I factor these two guys. So what do I get? If I factor those two guys, I get the c1 e to the alpha x plus c2. Oh, well, I also can factor e to the alpha x, right? So let's factor it. Oh, sorry guys. So let's just do it here. So I factor e to the alpha x. So I get c1 plus c2, right? And now I factor the other one. So in the other one, let's factor e to the alpha sine beta x, right? So I can factor those two. E to the alpha x times sine beta x. So if I factor that, what do I get? I get IC1 minus IC2. And then this is where we do magic. So this is C1 plus C2. What is C1 plus C2? C. So let's call it another constant. Let's call it K1. K1 e to the alpha x times cosine beta x. And then this is IC1 minus IC2. What is that? Just another constant. Let's call it K2. It can be complex, yes, it could be complex. But if the problem is good, probably it's not going to be complex. Okay? So we will run away from complex solution. Okay? So we'll try to keep it real. So you have a complex, maybe you'll have to change your initial data or something. And that's my general solution. That's y of x. That's how my solution looks like. Remember, all this was y of x from the beginning. yx, 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 and yx, yx. So congratulations, you have completed your formulas. So you have to memorize them. Okay? This is your new quadratic formula. So these three rules are really important. These three cases. They are as important as quadratic formula. So you cannot be an engineer like doesn't know how to solve this from memory. Okay? Just like you cannot be at the university and not knowing quadratic formula. So you guys need to know case 1, case 2, case 3, and this has to be very, very good, very proper. So any scientist, any teacher, the three cases should be implemented because it's derived from quadratic formula. So we will do some examples now. Let me stop here.